Hello dear students, very good evening to all of you. In today's session we are going to discuss about some good practice question, excellent practice question based on first order and second order control system, that is chapter number 2, time domain analysis. So we will have a discussion on the second order, that is standard transfer function omega n square upon s square plus twice zeta omega ns plus omega n square, basic standard function, transfer function, unit step response for a second order system, first order system, maximum peak overshoot, peak time, settling time, rise time, steady state error. So all the concept we are going to recall and we will revise through the good questions. Okay. So first of all, just confirm audio and video, guys. Am I audible perfectly? Yes. So those who are attempting this, attended the live session, guys, you should, those who are attending in a live manner, you should reply in chat box so that we can have a live interaction. So student, today's class I am going to start with this question. This question is look like very easy. All of you just try to attempt this question. Everyone try at least have a attempt. Yes. Do reply fast, guys. The question says that the response of a system for the step input is shown below. The CT value is given to us. The C of T value is given to us. Yes. Okay. So guys, CT value is given to you. The damped natural frequency omega D is also given. The settling time of a system for the 2% tolerance band is. So first of all, if I talk about the settling time formula for the 2% tolerance band, the formula is nothing but Ts equal to 4 upon zeta omega n. Now student, here zeta and omega n is required. And do you know, to calculate the zeta, examiner indirectly have given maximum peak overshoot. So it is a 2 marks level question as far as GATE exam is concerned. Such type of question will come, then definitely the weightage will be 2 marks. Try to solve this question fast, guys. I am waiting. Try to solve this question fast. I am waiting. All of you just need to attempt. Yes. So student, unit step response is given to you and this difference is given to you. It means indirectly maximum peak overshoot is given to you. An examiner is asking for settling time where you need actually zeta and omega n. So to calculate the omega n, omega d value is given to you, and to calculate zeta, maximum peak overshoot is given to you. Try to solve this question fast, guys. I'm expecting this question from you all. Chaliye. Yes. So student, if I talk about maximum peak overshoot here, the maximum peak overshoot is nothing but here percentage max is 1.10 minus 1 upon 1 into 100. So it is nothing but 0.1 into 100. So percentage MP you will get as a 10%. If MP is 10%, guys, without in percentage it will be 0.1 only, 0.1 only. And we all know that MP formula, the MP formula is nothing but e to the power minus zeta pi upon root of 1 minus zeta square is equal to 0.1, is equal to 0.1. So student, from here when you will take ln both side, log both side, the zeta value that you will get after this, it is 0.59. If you are my classroom student, then I hope you remember, we have already remembered the zeta values for the standard overshoot. Suppose that if overshoot is 10%, zeta is 0.59. If overshoot is 25%, zeta is near to 0.4. If overshoot is 5%, zeta is near to 0.7. And we all know that MP and zeta are reciprocal and MP and theta are proportional to each other. So now student, you are getting zeta value from here. And if you will see this omega d, here omega d value is nothing but actually omega n root of 1 minus zeta square. And do you know what is omega d? Omega d is nothing but 3.23. Omega n we are looking for under root of 1 minus 0.59 whole square. And when you will completely calculate it, just calculate it, guys, you will get the value of omega n. If you have a calculator, then you can calculate it. I am waiting. If you have the calculator, just do calculation, guys. So by calculating this, you will get the answer. So omega n will be, when you will calculate this 3.23, omega n will be near to 4, guys. Omega n will be near to 4, yes. So your answer will be, omega n will be near to 4 radian per second. So answer finally, settling time asking for, so TS is nothing but 4 upon zeta omega n. Zeta is 0.59 and here is omega n is 4. So 4 get cancel out. So your settling time will be 1 upon 0.59. So I think it is 1.689 something. 1.69 something. 1.69 something. Shabash, yes. So I think Akansha is here. Akansha, second. Very good, beta. Akansha, 1.2 watt, beta. 1.2 watt. Final answer is 1.69, no? When you will calculate this value, you will get omega n near to 4. Yes or no? Just calculate it and let me know. Just calculate it and let me know, okay? Yes, do reply fast, guys. I am expecting correct answer from you all for this. Is it clear? So I think for this question, settling time, I hope you calculated. This is our question number 1, guys. Multiple concept has been involved here. We can save the time here. If you are not able to remember this, then definitely you have to calculate it, and while calculating it itself, it will take 50-second time or approximately 1 minute time. Acha, zeta 0.6 liya, 0.59 or 0.6 also you can take, no problem. But still it should not differ by, final value should not 1.2 beta, it should be near to 1.6, 1.5 or 1.7, it is near only. Okay, you can calculate later also, no problem. You can calculate later also. Okay, chali. So now we are going for the next, guys. I should take the white background only. So let me take the light theme. Okay. So student, you should tell me here. I told you some values you need to remember. Some values you need to remember. If I talk about, guys, zeta. If I talk about zeta 0.4, then your MP value is near to 25%. Yes or no, Akansha? If zeta value is 0.5 exactly, then MP will be exactly 16.3%, near to 16%. Yes. If zeta value is 0.59, then MP value is exactly 10%. And if your zeta value is 0.7, then your MP value going to be 5% approximately. So you can say that as soon as the zeta value increases, the MP value going to be decreases. And we all know that MP is reciprocal to 1 upon zeta, and MP is always proportional to theta. Yes or no? Because we know that cos theta is equal to zeta. Is this clear to you, guys? Is this clear to you? Chali. Akansha, Vasist, do reply fast. Other students will also reply. I can see other students are also attending live manner. So this is my question number 2. Beta Akansha, do you like to attempt it? Akansha, do you want to attempt it, or you want I will explain the solution directly? Tell me. Do reply fast. Do you need time for attempting this, or shall we go for directly solution? Chali. At least let's have an attempt, guys. The closed loop directly CLTF is given to you. The closed loop transfer function of a system is given to you. The steady state error of the system for the ramp input is. The steady state error for the ramp input is. Come on, guys. Try to attempt this question fast. I want to see how many of you are able to attempt it. Do it fast. Do it fast. Do it fast. Yes, guys, do reply fast. Shall we go for next or not? Yes or no? All of you guys just let me know. So, I think Akansha has replied. Akansha, are you attempting this? Chali. Okay, guys. So, student, if such type of question will come, you can use this formula ESS equal to limit S tends to 0, limit S tends to 0, SRS whole bracket close 1 minus closed loop transfer function. So if you heard any of the classes, you know this formula. You just need to put the values, guys. So it will be limit S tends to 0, S. What is RS? The Laplace transform of the input signal, that is nothing but ramp input. So it will be 1 upon S square and 1 minus CLTF. So it will be 2S plus 3. It will be 2S plus 3 upon S square plus 4S plus 3. S square plus 4S plus 3. Whole bracket close. So student, what you will get here? You will get limit S tends to 0, S dot. So here 1S and 1S will get cancel out. So 1 by S. And when you will take LCM here, you will get S square plus 4S plus 3 minus 2s minus 3 upon s square plus 4s plus 3. So now student, just apply this. So 3 and 3 get cancelled. So ultimate term will be what? Ultimate term will be limit s tends to 0. Limit s tends to 0. 1 by s is outside only. Here you can take outside s. So inside the bracket you will get s square. 4s minus 2s, so it will be 2 actually. So s into s plus 2 upon. Because 4s minus 2s, it will be plus 2s. So s will be get cancelled out. You can take outside, and now after that it will get cancelled out. And you will get s square plus 4s plus 3. So now when you will apply the limit, guys, you will get the answer 2 by 3. Is this clear to you? Is this clear to you, guys? Just do reply first. The final answer that you are supposed to type, it will be 0.667. Do it fast. Do it fast, all of you. Just complete this question fast. We'll go for next. So I think question number 2 is also clear to you. Now I'm going for the next. Now we are going for the next. Come on. Question number 3, it is very good question. And the classroom students can easily solve this question. I hope they can remember this question also. So if you know about the basic idea about the definition of maximum peak overshoot, you will not do mistake in this question. But generally there is a scope of mistake. If you will directly calculate the maximum peak overshoot by just taking the difference, maybe you will do mistake here. Okay, just try to attempt fast. Just guys try to attempt it fast. Yes. Okay. Let me see how many of you able to solve this. Come on. So student, if I talk about the maximum peak overshoot, this maximum peak overshoot definition is what? Percentage of MP is nothing but x minus ka 2. It means maximum value minus final value upon final value. So this is nothing but your maximum peak overshoot, guys. It means if zeta is 0.5, earlier slide only I told you, if you are able to remember the standard values of overshoot for a standard values of zeta, then you can save your time. So because of zeta 0.5, MP is near to 16%, guys. MP is near to 16%. And to maintain the MP 16%, this distance should be the 16% of 2. It means that difference should be, because divide by 2 only, so the difference should be 0.32. So this value should be 2.32. How, sir? If this value is 2.32, x value is 2.32 minus 2 upon 2, then only you will get 100%. Then only you will get 16%, because 0.32 minus 2 upon 2, so it will be 0.16 into 100. Now you will get. So correct answer for this question is nothing but C for Chennai, 2.32. You will say that कि 0.32, you will say that कि 0.32 is 16% of 2. 0.32 is 16% of 2. Is this clear, beta? Yes or no? So I think this question is also clear. You are only able to solve this question fast if you are able to remember this. If you are not able to remember the standard value, then in the examination hall you have to perform this. You have to perform this. Zeta value 0.5, so you have to write like this: e to the power minus zeta pi upon root of 1 minus zeta square, and wherever is zeta, you need to put e की power minus का 0.2 pi upon root of 1 minus 0.5 का whole square, and when you will calculate this and multiply with 100 in the form of percentage, you will get 16 point, otherwise you will get 0.163 something. When you will calculate, you will get this. When you will calculate, you will get this. Yes. Chali. So now guys, question number 3 is also clear. Now question number 4. This is your question number 4. Control system, question number 4. Try to solve this fast. Try to solve this question fast, guys. A unity negative feedback system, a unity negative feedback control system is characterized by the open loop transfer function this, 30 upon s into s plus 2 s plus 5. The steady state error when the above system is subjected to input this 5 plus 3t into ut. So this is your input, r of t, input is given to you 5 plus 3t whole bracket close ut. 5 plus 3t whole bracket close ut is. And what examiner is asking? Steady state error when the above input subjected to this. So here you will observe clearly, guys, here you have a two input combination, one is step, one is ramp. So you can find the error with respect to Kp, Kv combination. I'm just giving you a hint, at least you should have a try. At least you should have a try, guys, yes. You can take two input combination, one RT as a 5 into ut and other is nothing but 3t ut. And student, if you know the standard table concept from by the steady state error, you will get to know here what is the type of the system. The type of the system is 1, guys. The type of the system is 1. And the table says that the steady state error for the type 1 system and step input will be 0 only. The table will says that, if you remember the table, this is how you can make the table, and you can remember the table for a long time. I hope you remember. Yes. So this is nothing but the for step input, this is for ramp input, and this is for the parabolic input. And this is what, guys? Type 0. This is for type 1, this is for type 2, and this is for steady state error. So answer is 1 upon 1 plus Kp here. Here is infinity, here is infinity. Here is also 0, here is 1 upon Kv and infinity, and 0, 0 and 1 upon Ka. Like that we have, guys. So you will say that, sir, because this system is having type 1, the step nature contribute in the error will be 0 only. And as far as ramp input is concerned, steady state error will be 1 upon Kv, but if there is any magnitude of the ramp, then it will be actually A upon Kv. So what is the A value here? For this question, A value is 3 actually. Now I am calculating the value of Kv. What is Kv? Kv is nothing but limit s tends to 0, s into g of s. Limit s tends to 0, s into g of s. So ultimately it will become limit s tends to 0, s into, what is g of s, guys? 30 upon s into s plus 2 plus s plus 5. S plus 2 plus s plus 5. So ultimately s's get cancelled out. When you will put s equal to 0, 5 to the 10, so Kv value is nothing but 3. Bolo beta, yes or no? Is it Kv value 3 or not? So your Kv value will be 3, and once your Kv value 3, your final answer steady state error will be what? A is 3 and Kv is also 3. So 3 by 3 cancel, answer is 1. And answer is 1 means option number B for Bombay. Yes. Bolo bachcho, yes or no? Everyone, guys, to reply fast. Is this completed? Is this completed, pyare bachcho? Yes or wait? Yes. So answer will be 1. Answer will be 1. Chale guys, shall we go for next question? Now we are going for the next. Actually today we have scheduled the class at 7 p.m. but due to some technical reason now we have shifted to 9 p.m. So I think students are not aware about the session. No problem. They will watch in the recording, guys. But if you are watching session in live, you should reply. Okay, no problem. So chaliye, shall we go for next? Question number 4 is completed. Correct answer is B. Now we are going for the, it is again a very good question, guys. Which of the following equation gives the steady state error for the unity feedback system excited by this input, where this is having the step nature, this is having the ramp nature, and this is having the parabolic nature. It is nothing but the standard formula is nothing but the question only. Standard formula is nothing but the question. Bolo bachcho. We all know that the steady state error for the step input is 1 upon 1 plus Kp and ramp 1 upon Kv, and for the parabolic 1 upon K. So you should tell me, guys, what is the answer? It is perfectly t square by 2 into ut. So it's a by ka only. So correct answer is nothing but the formula itself. It means option number D. So it means no calculation required in this question. Only formula is sufficient to solve this question. If you know, remember the formula, if you know the concept, just tick mark on the option number D and you can go for the next slide. Yes or no, pyare bachcho, just do reply fast. I hope this is clear to you. Chale. So I think this is the question number 5. This is the question number 5. Okay. We'll solve 10 questions back to back, guys. So 5 questions we have completed. Now this is a very good question. This is question number 6. The block diagram of a closed loop control system with non-unity feedback system is shown below. For equivalent unity feedback system, the forward transfer function is. Very good question, guys. How many of you remember how to convert a non-unity feedback to a unity feedback system? I hope you remember, we have did this earlier. So it is plus minus, guys. This value is g of s, this value is g of s, this value is h of s. So you want to convert this non-unity feedback to the unity feedback system. It means this is your g of s and this is your h of s. Yes. So this is your r of s, this is your c of s, and like that we have, this is your r of s, this is your c of s. So this is the non-unity feedback to unity feedback, but of course that OLTF will going to be changed. And I hope you remember that equation, guys, gs upon 1 plus gshs minus gs. Chali. So our new g dash s will be what? Your new g dash s will be nothing but g of s upon 1 plus g of s h of s minus g of. So this is the complete derivation. I hope you remember in the classroom we have did this. So here what is the value of gs? This is the value of g of s and this is the value of h of s. I want that you need to do this calculation, guys. What examiner is asking? Examiner asking the forward transfer function. It means the equivalent unity feedback system, the forward transfer. It means asking for g dash s only. Examiner is asking for g dash s only. And you need to put this value g dash s is nothing but actually gs upon 1 plus g of s h of s minus ka g of s. And do you know what is the gs value, hs value here? What is gs? K upon s into s plus 1. So I am just putting the value. K upon s into s plus 1 upon k upon s into s plus 1 upon 1 plus again k upon s into s plus 1 tan upon s plus tan. So tan upon s plus tan gs upon 1 plus gs hs minus ka gs. Minus gs means k upon s into s plus 1. K upon s into s plus 1. Yeah. So now this is your g dash s value, guys. Now this is your g dash s value. Now you are just looking for just left with the LCM part. Just take the LCM, guys. So numerator, when you will take the LCM, k will only left because s into s plus 1, s plus 10 is the LCM. So s into s plus 1 get cancelled out, but still s plus 10 will be in the numerator. And here what you will get? Here you will get s into s plus 1 into s plus 10 plus 10k and minus k whole bracket close, because s is s into s plus 1 already there. So you are left with s plus 10. Yes or no? Now the numerator part is nothing but k into s plus 10, and complete denominator when you will simplify, guys, you can even multiply also. So what you will get? You will get s square and s, so it will be s cube. Now you should check the options also, whether in the options actually it is multiplied or not. In the options whether it is multiplied or not. I think it is multiplied in the options. Yes. So we'll also multiply it, no problem. So s square, so s cube. Now tan s. So it will be tan s and 1 s 11s. So 11s square and plus tan s and plus tan k minus ka ks minus ka tan k. So don't you think this tan k negative and positive will get cancelled out? So your ultimate term will be what? Your ultimate term will be k into s plus tan upon k into s plus tan upon s cube plus 11s square, s cube plus 11s square plus 10s, s cube plus 11 square plus 10s, or even you can take common in also 10s minus ks. So here I can write 10 minus k into s. So ultimate answer can be k into s plus 10. Throughout the s, throughout in the denominator, s can be cancel, can be take common. So s square plus 11s plus 10 minus k. This is nothing but your final answer, guys. So final answer is given in which option? K into s plus 10 upon s square plus 11s 10 minus k. S square plus 11s 10 minus k. K into s plus 10. I think this is the only option, guys. S square, s cube plus, it is s square actually. It should be s square now. This is s square, then only option satisfy. Yes, it's typing error. K into s plus 10. K into s plus 10 upon s into s square plus 11s plus 10 minus k. Option number C. Bolo. Option number C for Chennai is the only correct answer, guys. Shabash. So those who are doing this, do it fast. I think it is an easy question, but you can only solve this question if you remember this expression. So if you know the concept, you can solve this question. It is a good question. Conversion of a non-unity feedback system to a unity feedback system. Chali. Again going for the next, guys. Here we have next question. If the closed loop transfer function, Ts of a unity negative feedback system is this is the question. Now, then the steady state error for a unit ramp input is. Then the steady state error for a unit ramp input is. Try to solve it fast, guys. Your ramp input. Actually, I am just giving you a hint because here unity negative feedback system is given to you. Here unity negative feedback system is given to you. So can you find out the OLTF from the CLTF? If you can find out the OLTF from the CLTF, then you can directly apply the formula 1 upon kV because ramp input asking. If the system will become type 1, then only you can apply. Or you can use the table also, yes or no? So student, I know the short trick how to write OLTF from the CLTF. So what can I write? Numerator will be remain same, sir. Numerator will remain same, that is an minus 1 into s and plus an upon student, you should tell me the numerator part you need to subtract from here. So an and an minus 1 s will be subtracted. So what is s square throughout common, guys? S square throughout common. So here s ki power n minus 2 plus a1 and s ki power n minus 3 and so on you will get. And so on, the last coefficient you will get an minus 2 only. Why? Because this part going to be subtracted. This part going to be subtracted. So don't you think because it is OLTF, the number of open loop poles lie at origin decide the type of the system. So the type of the system is nothing but 2. And because this system is having the type 2, the steady state error for the type 2 system and ramp input will be always 0. Type 2 system, it means third row. Type 2 system, we have just did this table I have made here. Type 2. Type 2 and ramp input. This is type 2 and this is ramp input. It will eventually meet at 0 only. Type 2 and ramp input meet at 0 only. Type 2 and ramp input will meet at 0 only. Bolo hai na? I hope this part is crystal clear, guys. I hope this part is crystal clear, guys. Yes. Chale. So 5, 6. This is of course a 7 question. Question number 7. Question number 7 now. Here student, question number 8. Try to solve this question fast. Read this question and try to solve it fast, guys. Read this question and try to solve this question fast. A control system is represented by the given differential equation d2yt upon dt square 4dyt upon dt plus 8yt equal to 8xt. The ratio of rise time and the time at which second overshoot occur is, where yt is output and xt is input. We know that, guys, whenever any system is represented by a differential equation, we need to take Laplace transform both sides. We need to take what, guys? Laplace transform both sides. We need to take Laplace transform both sides. Yes. So when you will take the Laplace transform both sides, guys, what you will get here? you will get s square because of transfer function case initial values are 0. So s square y of s plus 4s y of s plus 8 y of s is equal to 8 x of s. So when I will take common in y of s, guys, what you will get inside the bracket? When you will take common in y of s, inside the bracket you will get s square plus 4s plus 8, and it is nothing but 8 into x of s. So ultimately you will get actually ys upon x of s is actually 8 upon s square plus 4s plus 8. S ys upon x of s equal to 8 upon s square plus 4s plus 8. This is your transfer function, guys. And do you know, if the second order standard transfer function is given to you, examiner is asking for the ratio of rise time. Do you know the rise time formula? The rise time formula is nothing but pi minus theta upon omega d. And this is asking for the time at which the second overshoot occur. It means asking for the second peak time, TP2. And do you know the first peak time, pi upon omega d? The second peak overshoot occur at 3 pi by omega d. So 3 pi by omega d is here. So examiner is asking for this ratio. It means when you will take the ratio of this, TR upon TP2, you will eventually get pi minus theta upon omega d, or overall upon में 3 pi upon omega d. And you will get to know omega d get cancelled out, sir. So your ultimate answer will be what, guys? Examiner is asking for the ratio. So your ratio will be nothing but pi minus theta upon 3 pi. And do you know what is theta, guys? Theta is nothing but, cos theta is nothing but zeta actually. So when you will write here, omega n value is nothing but root 8. And if you will write twice zeta omega n, so twice zeta omega n equal to 4, guys. Twice zeta omega n equal to 4. Omega n is root 8. So 2 into zeta, omega n is root 8 means 2 root 2 equal to 4. So don't you think 2 2 ja 4, 4 get cancel out, sir? So zeta will be 1 by root 2. And if zeta will be 1 by root 2, guys, your cos theta will be actually zeta. So theta is nothing but pi by 4. Theta is nothing but 45. If theta is 45, we are just looking for theta value here. So your answer is pi minus pi by 4 upon 3 pi. This is your final answer. And when you will just subtract this, so here I am making some space. So ultimately it will be 3 pi by 4 upon 3 pi. Because pi minus pi by 4, 3 pi by 4 upon 3 pi, so answer is 1 by 4. It should be 0.25, guys. It should be 0.25. Bolo hai na. It should be 0.25. Yes. It should be 0.25. 0.25 or near to 0.25, 0.24 also. It can be, yes. All of you guys do reply fast. Shall we go for next? Bolo yes or wait. .25. Correct answer 0.25. Shabash. Chali. So now I am going for the next guy. This is the question. Very good question expecting from you. The S-plane diagram of a second order system is shown below. So this is your sigma value. This is sigma value. This is also imaginary value pole. The time for which the response of a system achieve maximum value in second attempt, for unit step input is in seconds. What is this, guy? Just let me know. So here is real value, here is imaginary value. The time for which the response of the system achieve the maximum value in the second attempt unit step input. Second attempt, maximum value second attempt. Again the same formula, TP2 is nothing but 3 pi upon omega d. And do you know what is omega d? It is very easy question, guys. The time for which the response of system achieve maximum value in second attempt. So it means first attempt TP. If you will make the diagram, you will get this. You will get this shape of the diagram. So this is nothing but TP1. that is standard maximum peak overshoot. This is your TP2. This is nothing but pi by omega d, and this is nothing but 3 pi by omega. This is nothing but your maximum peak overshoot 1 MP1. This is nothing but your MP2, like that we have. So now simply you should tell me guys 3 pi by omega d, and do you know what is omega d? If you will connect with here, this is 6, this is 8. So of course this will be 10. Of course it will be 10. So omega d is this only. So answer will be 3 pi by 8 only guys. Answer only 3 pi by 8. Bolo hai na? Just do reply fast. Are you guys getting the same or not? Just let me know. Answer goes to 3 pi by omega d. And when you will solve this 3 pi, you will get answer 1.17 something. When you will solve this, you will get the answer 3 multiply with 3.14 upon 8. So your ultimate answer will be, when you will calculate it exactly, you will get 1.177. 1.177, near to this. 1.18. 1.18, yes. Chali. So now we are going for the next guys. Again, chaliye. Next, this question will solve first. After that, other questions will come. Which of the following complex roots relate to the greatest value of omega 1? Come on guys, omega n. Greatest value of omega 1. Come on. Try to solve this question first, all of you. Yes. So student, do you know कि whenever we have a complex conjugate pole na, this is your conjugate pole, this is your real value, this is your imaginary value. What is the real value? Real value is here, whatever the real value, and imaginary value is here, yes. And this is nothing but Pythagoras theorem, under root of this square and this imaginary part square. It means this distance and this distance. So distance never negative or never imaginary. So minus 1 and 1. If I will calculate for this minus 1 and 1, if this distance is 1, this is also 1. So this distance is root 2 only. So for this omega n value is nothing but root 2. For this, what is omega n value guys? For omega n for this, 2 ka whole square 4 or 1 ka whole square 5. So root 5. 4 and 3, so under root of 16 plus 3 and 3 ka whole square 9. So under root of 16 plus 9, that is nothing but under root of 25, and it will give you 5. And here what you will get? Here you will get under root of 4 ka whole square 16, 2 ka whole square 4. So root 20. So which is the greatest value? One value is root 2, root 5, 5 and root 20. So of course 5 value is the maximum. Correct answer for this question is option number C for Chennai. Correct answer for this question is nothing but option number C. Chaliye bhai. So I think this is clear to you. I hope all of you guys completed this. Shall we go for next? Just let me know. Shall we go for next guys? Okay. So now we are going for the next question. As I told you earlier, the session was scheduled to 7, but due to some urgent work or technical reason, we have shifted this session to 9. So students are not aware about it. Chali, no problem. Maybe student will watch in the recording. The open loop transfer function of a unity feedback system is given by this. This is nothing but the G of S value guys. Consider the following statement. The steady state error for a step input of magnitude 10 is equal to 0. The first thing that you should note down, unity feedback system, it means it is working as an open loop transfer function. And if it is an open loop transfer function guys, the system is having the type 1. The system is having the type 1. And you know that if system is having type 1, what is its error for the step input? For the step input type 1, error will be always 0. Error will be always 0. So this statement is 100% true guys. The steady state error for the ramp input. If the system is having type 1 and for the ramp input, the error is nothing but 1 upon kV guys. And don't you think 1 upon kV or A upon kV? A upon whatever A, A is nothing but the magnitude of the ramp. The steady state error for the ramp input of magnitude 10. It means it is nothing but 10 upon kV. So if I will write the formula of kV, kV is nothing but limit s tends to 0, s into g of s. G of s value completely you need to put here. So 5 into 1 plus 0.1 s upon, here you will get again s into 1 plus 5s and 1 plus 20s. So don't you think guys SS get cancelled out? When you will put s equal to 0 finally you will get kV 5. So your ESS value is nothing but 10 upon 5 and 5 2 are 10. So answer is 2. So this statement is also true guys. Second statement is also true guys. Bolo हाँ या ना? बोलो बोलो बेटा हाँ या ना? Career impact. No problem beta, actually it is an unplanned session, so not informed to students. Okay. The steady state error for a acceleration input of magnitude 10 is infinite. Which one of the following is given above correct? The steady state error for an acceleration input of magnitude 10 is infinite. Now tell me guys, because the system is having type 1 and you have the input acceleration input coefficient k means parabolic input combination, it means it for sure it is infinity only, because in the table says that the steady state error for the type 1 system for the step input is 0, for the ramp input a upon kv, and for the parabolic input infinity. So third statement is also true. So correct answer is 1 2 3 only. So correct answer is beta 1 2 3 only. Yes or no beta? I hope this is clear to you. I hope this is crystal clear to you. Yes. Okay guys, so that's all from today's session guys. Actually this session I have planned at 7 p.m. Again I am repeating, I already told you, but 7 p.m. we are not able to start the session. No problem. So no problem guys, the students can watch in recording. I know, no problem. Bye bye guys, take care. And or tomorrow signal system session also going to be shifted guys, because tomorrow we have in Karnataka, Bangalore is tomorrow we have a Karnataka Bandh actually, so Bangalore is also we can say that office is also closed tomorrow. So tomorrow signals and system YouTube class also going to be shift on day after tomorrow. Okay, it means not on Tuesday, it will be on Wednesday. Okay guys, so bye bye, take care. That's all from today's class. Thank you.